Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we introduced 2SLS with the simplest possible case, one endogenous variable, one instrument, but in practice we know models are rarely that simple, so you might have multiple control variables, multiple endogenous variables, and if you're lucky, multiple instruments. This video will generalize the setup so you know exactly what 2SLS looks like in the real world, and you can easily adapt it for any number of variables or instrumental variables that you might be given. In the most simple case, we started from a very simple model, beta 0 plus beta 1x. Instead, here we're going to modify this model and make it a little bit more complicated. So we're going to add a beta 2 x2 and many other x's, which we are going to assume are all your endogenous variables. So let's say we have until bk xk. So once again, x1, x2 until xk, these are all your endogenous variables. And we're also going to assume that you have control variables starting from w1, w2, and let's continue until wk. And ultimately an error term. So we got w1, w2, wk, exogenous, and we're going to assume that we have many instrumental variables, z1, z2, and so on. Okay. Most real applications, keep in mind, have control variables alongside the endogenous variables, and at any stage in here, we're going to assume that these control variables are exogenous. Also, what will come quite obvious to you is that they will show in both stages of the 2SLS procedure, okay? The instruments, as usual, are going to be excluded from stage 2. Remember, we didn't use them. They appear only in the first stage. Now, a very common source of confusion in here for students is that control variables, W, keep in mind, they are not instruments, okay? They are included in both stages because they are exogenous. Instruments are excluded from the outcome equation because that's the whole point of the exclusion restriction, okay? Now, the first stage, how does that change the moment that we now have this bigger regression population model? In the simple model, we had simply X as a regression on Z. In this particular case, now what we're going to have is X1 equal to pi 0, pi 1, Z1 plus pi 2, Z2, and all of the other Zs that we have in our model, plus we're going to now add all of the control variable which were exogenous. So let's say delta 2 W1 plus delta 1 W1, delta 2 W2, and so on until delta K WK plus an error term. Keep in mind in here, we're not including the endogenous variables. Is X1 on all of the instruments and all of the control variables. And as usual, through OLS, we're going to get X1 hat. Now, remember, X1 is not the only endogenous variable that we have. We have X2, X3 until Xk, which means that stage 1 will have to be repeated and you have to run as many regressions as endogenous variables that you have. So if you have xk endogenous variables, it means that you're going to run x1 regression, you're going to run a regression for x2, which you can put all kinds of Greek letters in here. I'll just pick the same ones, but keep in mind they will be different numbers. But look again, so I'm including for x2 exactly like x1, all of my instrumental variables and the control variables. And out of here, I'm going to take x2 hat, then I'm going to take x3 hat until I get also xk hat. Okay, so we run as many regressions necessary as we have endogenous variables so that we can get all the uncontaminated versions of all of our endogenous and contaminated variables. Okay? The control variables, they are exogenous and their variation is clean, and they should be used to predict x, basically x1, x2, x3, as precisely as possible. So after we've run this many regressions on stage 1, then we can move to stage 2. And it becomes a little bit clear what the pattern is now. So if in the simple case we only had y equals to b0 plus b1 x1 hat, now we're going to have b2 x2 hat, and so on until bk xk hat. And we're going to reintroduce again all of our control variables. So since we use gamma 1 in here, W1 plus gamma 2 W2, and so on. We run these through OLS and we can get beta 1 IV, we can get beta 2 IV, and so on. Okay? So, again, in practice, you will never run these two stages manually, okay? So that you don't have to also manually add every time at every stage and do all of these many regressions, K regressions that you've got in stage 1. Stata or R will do that for you in the background. So luckily you don't have to do them manually. The software does it all in one go, running manually again. The same result that we had from the previous video will apply here, that you might get the correct coefficients, but you're going to get wrong standard errors if you run it manually. So it's best to just make sure you leave it to the software and to the actual command used for IV in those softwares to do all of these regressions. Okay. Now, suppose that for a moment we have two endogenous variables, x and 1. You are going, so this is a much simpler case now. Keep in mind, for your first stage, what you're going to get is x1 equals to pi 0 plus pi 1 z1 plus pi 2 z2 plus, let's say we only have one control, and v1, then x2 you're going to have pi, or we can switch again so that you know these are different coefficients, say gamma 0, gamma 1 z1, gamma 2 z2 plus delta w plus v2. Okay, so in this particular case, as you can see, each of these two will get their own regression. Both instruments appear in both the first stage and this, like for the regression of x1 and the regression of x2. And each instrument in here is helping predict both endogenous variables. Okay, and ultimately for the second stage, what you're going to have is simply y equals to beta 0 plus beta 1 x1 hat plus beta 2 x2 hat plus alpha w plus an error term u. Okay. In general, this sort of procedure and the fact that you're using these instruments help predict both endogenous variables should be also a hint of like why is always good to find good instruments. And the thing is that finding good instruments, unfortunately, becomes exponentially harder when you have more endogenous variable, because each additional endogenous variable requires, okay, at least one additional credible instrument. And in practice, models with more than two endogenous variables are rare precisely because instruments are so hard to find. So it's very likely that in most of the cases, even in exam conditions, this sort of procedure is at most the one that you will be asked to reproduce without having to do as in the very generic case, add all of those k z's or k control variables in your regression. Okay. Now, regardless, keep in mind one thing, regardless of how many variables or instruments you have, the logic will never change, okay? So first stage, predict each endogenous variable using instruments and controls. Second stage, use predicted values in place of endogenous variables. More variables, more instruments, but the same two steps always remain the same. And this is why understanding the simple case first was so valuable, because once you have the intuition, then this general case or this more specific case here with two instrumental variables, then it's a lot more easier to see how it applies. However, this is not enough. So we now know the general setup and what it looks like. What we haven't asked yet as a question is how many instruments, though, do we actually need? And do they need to satisfy any additional conditions beyond relevance and exclusion? And these questions lead us to two important conditions, and they are called the order condition and the rank condition. We'll cover each one of these in the next two videos, but for now, remember, in general, 2SLS, each endogenous variable gets its own first stage using all instrument and exogenous controls. The two-step logic from the simple case simply scales directly to any number of variables. So in the next video, we'll cover the order condition. So stay tuned and I'll see you then.